Hi, everybody. Now I'm going to go over number 2. Notice the degree is 4, which means it has to have 4 zeros. They're not all real. Some of them could be complex. This is where everything comes together in this example here. So once again, I've given you a 0, but this time I gave it to you in function notation. So this is the x, right? And that's saying that when I put in a 3 for x, I get a 0 for y. Well, that's the definition of a 0. So this basically is another way of writing that x is equal to 3 is one of my zeros. And I need to change it into a factor form to be able to do my division. Or if you do synthetic division, you don't have to do that. So x minus 3 is one of my factors. So I'm going to take the polynomial and I'm going to divide by one of my factors to see what's left and to see how to factor that. All right, I'm going to do long division again. What do you multiply x by to get x to the 4th? Obviously x cubed. This is all review. So x to the 4th minus 3x cubed. I didn't put a 0 for the x squared, so just be careful with that. That cancels and that cancels. So then I bring down the negative x. I'm going to go ahead and bring down the 3 too, just in case. Look at the first term. What do you multiply x by to get a negative x? A minus 1. And then when I distribute that, I get this. And so there it is when I divide. Now, you know how to factor this. This is a difference of cubes. Remember the rule we learned? So I'm going to take the cube root of that, which is x, the cube root of that, which is a 1. And then if this is a negative, that means this is a negative. And then you square that term, put it there. Square that term, put it there. Multiply, put it in the middle. 1 times x is just 1x. And if this is a minus, it's a plus and a plus. Okay, awesome. Now, here's the problem with this one. This gives us x equals 3 for a 0. This gives us 1. These are real solutions, or real zeros. We have 2 of them. This is going to give us 2 complex. Let me show you why. To figure out what the zeros are, you have to take this whole thing and set it equal to 0. Since I can't factor it, I need to solve using the quadratic formula. Okay, remember that guy? So negative b plus or minus the square root of b squared minus 4ac all over 2a. So that gives me negative 1 plus or minus the root of negative 3. And then remember our complex lessons with the I. The square root of negative 1 comes out as an I, and I'm left with the positive 3 in there. So these are 2 more roots, because you have to have 4 roots, but 2 of them are complex, which means when you graph it, there's only going to be 2 dots on the x-axis. So let's graph those. So we have 1, and then we have 3. So we need to figure out what's happening in this graph. So one of the easy things that we do is to find the y-intercept. So you can use the original, you can use the factored, it doesn't really matter. The original is actually really easy to do, because if you put a 0 in here, you just get 3. So that is your y-intercept. And then in between here, in between the 1 and the 3, I'm going to go ahead and plug in a 2. When I plug in a 2, I get 2 minus 3, and then 2 minus 1, and then 2 squared plus 2 plus 1. Well, this gives me a negative, this gives me a positive, and this gives me a positive. So ultimately, I'm going to have a negative, which means between here and here, I'm down. And then I obviously cross and then go up. So that's what that polynomial looks like. Has 4 zeros, 2 of them are complex, and 2 of them are real.